Alright, in order to find the inverse of each function, you're going to use that skill that we just practiced of rewriting log into exponential form, so be considerate of that. I'll do 12, you do 13 and 14. It's just like what we did in Module 6 as well. To find the inverse, you are going to first step, because the inverse technically means that the function is reciprocal along the line y equals x, and so for the given function versus the inverse of that function, the x values become the y values and vice versa. So that's why you switch the locations algebraically of the y and the x in the equation given. So my first step is to rewrite it as so: x equals log base 2 of y minus 6. That is the first step. Second step, again, because I said this earlier in one of the other videos, log and exponential are inverse of each other, so to find the inverse of a logarithmic function, I'm going to have to switch it into exponential. In order to do that, I'll speak it while I'm doing it. I find the base 2, draw my arrow to the other side of the equal sign. 2 raised to the x equals the outcome of y minus 6. So my second step is to rewrite it in exponential. 2 raised to the x equals the outcome of y minus 6. And then finally, in order to find the inverse, again, we've talked about this, I just solve for the variable y. In order to do that, this might be different, this process, for the numbers 13 and 14, but you just have to call upon your math skills. This 6 is being subtracted. I need to add it to both sides. So I get y equals 2 to the x plus 6. And then finally, the third and final step of finding the inverse is rewriting the inverse notation. F negative 1 of x, or the inverse of x, equals 2 to the x plus 6. And I'm done. Again, step 2 for 13 and 14 might look different just depending on the math, but that is the process you take to find the inverse. You first switch the y and the y's and the x's, then you rewrite it into exponential form, then you solve for y, and then you write it in function notation. And we're done.